Please welcome to the stage, Dirk Jan Mollema.
Hi, good morning. So who's ready to talk about some cloud stuff? So welcome, this is my talk. I'm your cloud, a year of hacking Azure AD. And I'm just going to talk about all the cool stuff that I researched and found in Azure AD the last 1.5 years, so a little bit more than 1 year. So first, a bit about me. I live in the Netherlands, and there I work at a relatively small company called Fox IT for a few years. We're part of a bigger company, NCC Group, that you may have heard of. They're also active in the US. And I like to research, basically stuff that interests me, and that's so far mostly been Active Directory and Azure AD. I did some tools regarding Active Directory, Midem 6, LDAP domain dump, and some Bloodhound things. And while I was researching Azure AD, at some point, I was writing so many reports to MSRC that they were like, hey, let's put this guy in a list. So I also was one of the most valuable security researchers this year. Thank you. So I write about my stuff on my blog. And one of the things that I wrote about was also Priv Exchange, which was, in Active Directory, a big thing this year. And of course, I have a Twitter account where I tweet about all the things I'm up to. But today, I want to talk a bit how I try to figure out how Azure AD actually works. So first I'll start with some of the Azure AD terminology, how it differs between different interfaces, and how the portal works versus how the API works, and some interesting things regarding that. Then I'll talk a bit about reversing Azure AD. It's not really reversing because it's cloud, of course, but just trying to get an idea of how it really works under the hood. Then digging into service principles, some funny stuff, and finally talking about, okay, what happens when you link up the cloud with your on-prem infrastructure. So to get started, what is Azure AD? Well, Azure AD is basically the source of authentication for Office 365, the Azure Resource Manager, so that's all the Azure infrastructure, and anything you want to integrate with it. Despite the similar naming, it has actually nothing in common with on-premise Active Directory, or almost nothing. So forget about everything you know on-prem and just see Azure AD as the identity platform for both Office 365 and for the Azure Resource Manager. So when you're talking about Azure AD, you obviously have some security principles. And there are 3 primary principles. It's obviously users. So these can be people in your organization that use Office 365 or any other cloud services. And those users, they have devices. These devices can be Windows 10 devices that you can join to Azure AD, but they can also be Android devices or iPhones that you can manage through the MDM options in Azure AD. And lastly, there's applications, which is a bit of a vague term, because in Azure, almost everything is considered an application. So the Azure portal, for example, is an application that's registered in Azure AD. The Microsoft Graph, which is an API, is also an application, Azure ATP, the Office 365 portals. And if you look at the default Office 365 installation, there are about 200 applications that are configured there. So since this is cloud, there's the concept called multi-tenancy, and that has an effect on how the applications are configured. So when we talk about applications, there's 2 distinct parts. First, there's the definition of the application, and second, there's the service principle. And the application definition is more like a template with settings and configuration options, whereas the service principle is actually the security principle that's present in Azure AD. So there are a couple of scenarios. The first, or the simplest scenario, is if you create an application yourself, then both the application definition and the service principle are present in your own Azure AD tenant. In the second case, where you are using third-party applications, then the third party makes the application definition, which is in their Azure AD tenant, And once you use that application, the service principal gets created in your own Azure AD tenant. And then there's, of course, all the Microsoft applications. So all the Office 365 applications, such as Exchange, OneDrive, etc. They exist in Microsoft Azure AD. They have a few internal tenants in which all these applications are defined. And once you create a subscription, then these service principals are created in your own Azure AD tenant. And we'll see why that's important on a couple of next slides. So related to this, there are application privileges. So when you create an application, you can grant that application privileges. And there are basically two types of privileges. One is delegated privileges. So these are privileges that if a user is actively using that application, then the application has privileges to, for example, read that user's email or read information about the user and the profile. These require a signed-in user to be actively using the application. Next to it, there are also the application permissions, which are more static permissions, so the application that can use them at any time. And these are assigned to the service principal. So the service principal is the actual object that has these rights to, for example, read information about users in a directory. And the way this works is that there's a permission model where every application can define permissions that it exposes, and then these permissions can be granted to service principals. So it's kind of like a circular thing. Every application can have permissions, and every application can define permissions that other applications can utilize. And commonly used permissions are for the Microsoft Graph or the Azure AD Graph, so that applications can read user information, access Office 365 data, etc. So an example of how this is configured. This is the application part in the portal. And here you see the API permissions. And we see that this application has two permissions, or actually three. So first is the delegated permission, which allows the application to access the Azure Active Directory as if it was the sign-in user. And the second is that the application, that's an application permission, so it's something the application can use at any time without the user. And that's the permission that it can read and write directory data. So these are application permissions that are defined in the application template. Now the permissions on the service principal are also visible. So we see that the permissions that were defined on the application are also granted to the service principal. So you can see here that it can read and write directory data. And for some permissions, it's necessary to grant these. So they first are defined that the application needs them, and then an administrator has to grant them so that the application actually uses them as a security mechanism. And there's a lot of confusion, at least there was a lot of confusion for me of how that actually worked. And it took me a long time to figure it out, because there's a lot of difference between how the portal says that things work with how the API actually says that it works. So for me, the API is kind of the more low-level thing, so I consider it leading. But the portal calls everything applications, whereas the API clearly has a difference between applications and service principals. And then the application defines OAuth2 permissions, which are the delegated permissions, and application roles, which are called application permissions in the portal. So the application defines which permissions it has, it exposes, and then application also defines which access it requires, and then these rights are actually granted to the service principal. But because of how this works, so normally you define required permissions in the application, and then the administrator has to approve them. But because this is actually just a role assignment that's granted to the service principal, it's also possible to assign this directly. And when you do this, then in the Azure portal, it will see, okay, so this application, it has a definition, and it doesn't require any permissions to any APIs. So that's good. However, when you move to the service principal view, you actually see that the application does have some roles that are granted. And next to that, you also see that the roles were approved by an administrator. So it doesn't actually say which administrator approved this. So if you manually add roles to an application, then you really have to be careful that it's actually very hard to see that in the portal. And of course, there is an exception, which are all the Microsoft first-party applications. And there's actually no way to tell from the portal or the API which permissions these applications have. So on here it says, okay, so this Microsoft Teams web client doesn't have any permissions, which is great, because then it's secure, right? But when I actually log in to Microsoft Teams, I get an access token, which is a JSON web token, and that specifies which permissions were granted to Microsoft Teams when I logged in. So we see here that in the scope, Microsoft Teams actually has quite a bit of access. And it has like access to read my calendar, to read my emails, and also to send emails, and it has these privileges on the Outlook API. As we see here, that's the same Microsoft Teams web client. So even though you can't see in the portal which permissions these built-in Microsoft applications have, they're still present and they're still kind of implicitly granted in your directory. Now, why does this matter? There are a few roles that allow you to manage any application in the directory, such as the global administrator, of course, because this administrator role can manage anything, or the cloud application administrator or the regular application administrator. And what they can do is that they can assign credentials to service principals. And then, of course, they can log in as these service principals and use all the permissions that the service principals have. So if an attacker gains access to an administrator role and can control these service principals, they can add credentials to these and use that as a persistence method, with the added benefit that since service principals are automated things, they don't have options for multi-factor authentication. Also, if you are granted permissions over an application that has more privileges than you do normally, it is, of course, possible to escalate these privileges by assigning credentials to the application and then switching context to the application itself. And it turns out that by default, there are quite a few applications that have more permissions than the application administrator role has. So here's a small list of default Office 365 applications. And you see that an application administrator normally should only be able to manage applications. But as you can see here, it can manage also all the SharePoint sites, it can manage groups in Azure AD, and it can even has read-write rights on all the objects. So that's quite some more privileges than you would think by default. Now, when you assign credentials to an application and then log in using that application, the log obviously shows that any actions performed in that context were performed by the application. So if an attacker grants credentials to an application, then waits for a while before the logs that they assign the credentials are rotated, and then perform actions under the application context, it's actually not possible to see who initiated these actions. And there's some more interesting things. So this was about the application permissions itself. And now it's about the OAuth 2, or the delegated permissions. And in OAuth, there's a specific grant flow called the password grant. So this is when you possess the username and password of a user, then you can use a specific OAuth flow to authenticate as an application. And I'm not sure how these permissions actually work or are assigned, but there are quite some applications that are allowed to impersonate the user when you sign in using that user. So, for example, the Azure AD PowerShell uses this. So you give it username and password, it signs in, and then gets a token that this application can basically use any privilege that you have normally. Now, this can be abused because if you use the OAuth 2 password grant flow, there's actually no verification that you're actually the application that you say you are. So you can just list the application IDs that are allowed to do these things, and if you then have the username and password, you can use any application ID to basically interact with the Microsoft Graph with the full user permissions. So this makes it possible to, for example, use Azure AD PowerShell with a different application ID than you would normally do. And if you're a defender looking at the logging and you are searching for specific usage of specific applications, such as the PowerShell application, then this is a way to circumvent this. So if you look at the unified audit logging, I hope it's a bit possible to read, but you can see that I signed in, and there are some GUIDs here. So the application ID on the bottom is actually the Microsoft MileIQ application ID, and I signed in to the Azure AD Graph. So because I can do this, it becomes much harder to find which activities I actually performed. Because if forensics people are looking for activities that were performed using, for example, the PowerShell module, they will have to search for this application ID instead of the application ID that's used normally. So I like to quote this tweet that if you're hunting for PowerShell activity, then previously there were already like 3 different indicators that you had to search for. But if you count also the application IDs that have the same privileges, then you can try to hide your tracks with about 6 other application IDs. So it becomes much harder to even find these tracks in Office 365. All right, so let's talk a bit about reversing or trying to understand how Azure AD works. So with normal applications, if you buy something, you install it, you can try to see as a researcher how this application works. You can try to use network logging, you can maybe attach a debugger to the application. But of course, it doesn't work for things that you purchase as a service, because it's running on some other system which you normally don't have access to. So it's not possible to have like a low-level access to the Azure AD backend and figure out, hey, this is how it works under the hood. You can't use the traditional reversing to find out, hey, how does this work, or how do I use this? And of course, the documentation only tells you, oh, this is how you should use our product, and not this is how our product actually works. So to look at how I could find more about this, I considered a couple of options. So there are a few ways to interact with Azure AD as a user or a developer or a researcher. First of all, there's the portal. There are some PowerShell modules, and then there are the APIs. So the portal, it looks very nice, and you can configure almost anything that in Office 365 and Azure AD that there is, but it does really simplify concepts, and sometimes it doesn't even display things. Like if I assign credentials to a built-in Microsoft Service credential, Microsoft application, that won't show up in the portal. You can only see it in the APIs and all the terminology differences. So it makes the portal not a very good candidate for actually trying to find out how it works. So there's also the APIs, and the PowerShell modules indirectly are a client for the API, so they're kind of considered the same. And if you're looking at the APIs, there's the Azure AD Graph, there's the Microsoft Graph, and Exchange Provisioning Services, and probably a lot of other stuff as well. So the Azure AD Graph, it's really focused on Azure Active Directory and only on Azure Active Directory, whereas the Microsoft Graph is the new API for like all of the Microsoft products and Office 365. So the Azure AD Graph is interesting, but it's a small thing, and the Microsoft Graph is really for all the products, so it makes it a bit harder if you just want to focus on reversing Azure AD. Lastly, there's Exchange Provisioning Service, which is XML-based, so I really try to avoid that one since it's horrible. But it's an older one, and it's already deprecated. You shouldn't be using it anymore. There are still some things that can only be done using the Exchange Provisioning Service. So it's a bit not always clear which one you should be using. So all the methods that I mentioned have different limitations, and some APIs have unique features, but they're already deprecated. And especially if you try to use the PowerShell modules, then you quickly find out that not all of them support these same authentication mechanisms. So for example, certificate-based authentication for service principals is supported by the PowerShell modules, but authenticating with password credentials for service principal is not. So Not everything is supported in the same module. Sometimes you need different modules. So that's a bit hard. And as I already mentioned, there's quite a difference in terminology between, for example, the portal and the APIs. And of course, the API that I actually try to use, or like to use, the Azure Active Directory Graph, is already considered legacy. And I'm told not to use it anymore, but it's still where I find most of my stuff. So, all right, so now it starts to be a little bit of guesswork, because as a researcher, I try to figure out, okay, how does this actually work? Because we have the Azure portal, and the Azure portal talks to the Azure portal API. I can see that in the request logs. But what does the Azure portal API talk to? Does it talk to some internal API? Does it talk to the Azure AD graph, the Microsoft graph? What's the backend? And is there another backend behind that? And what's in the end? Is there like a database? I don't know. So if someone's there who actually knows how this works, I'm very interested. But I'm guessing that there is at some point a database with all the data, and there are a few steps in between. And when I was looking at the Azure portal and what it's actually doing, once I found out a request, which was going to a bit of strange API, because I didn't recognize the response with the things I'm usually to. And it turned out that was called the 1.61 internal version of the Azure AD graph. Now, when you call something internal, it's like putting a big red flag with like, hey, security researcher, please look here, because it's internal, you're not supposed to use this. So obviously it was very interesting for me. And that learned that the Azure portal talks to the Azure portal API, but sometimes it also talks to the internal Azure AD graph API directly. And of course, as a researcher, you want to be at the closest point to the actual backend to get the most interesting information out of it. So I started analyzing this internal Azure AD graph API. And the great thing about these APIs is that they're based on a protocol or a standard called OData. And it means that they have a metadata definition which describes the whole API. And when I pulled the metadata definition, I could see that there was quite a difference in file size between the official supported APIs and the internal API. It's like almost twice as big. So there's a lot of more data in the unofficial API. And then you start looking around a bit, you scroll through that big XML, and you try to find interesting stuff. And there are actually some unannounced features in there, so I hope I'm not spoiling someone's talk on a conference next week or next month. For example, this is the definition for a group, and I noticed that a couple of months ago there was a new property for groups, which is called isAssignable to role. And if you're familiar with Azure AD, you may know that at this point in time, it's only possible to assign users to an admin role directly. But this kind of tells that support is in the work to also support having groups assigned to administration roles. So that's quite a big change. I tried to use this. It didn't allow me, because apparently my tenant wasn't enabled for this. But I could at least try. I'm very curious how this will work out in the future. And if you diff the metadata definitions, you also can find some new entities in there. So there seems to be some hints of DP API, which is quite well known for the Windows and Active Directory stuff, but I haven't seen it being used in Azure AD yet. So it's also something new. And there are some more interesting things, such as conditional access policies. If you look in the documentation, and there's a frequently asked questions, are graph APIs available for configuring conditional access policies? And the answer is no. And indeed, if I send a request to the API and I use the policies endpoint, it says, OK, there's nothing here. But when I change the API version to the internal one, then I suddenly get back a whole different result. And it turns out that this internal API version does support querying and changing conditional access policies. And unlike in the Azure AD portal, where you need administrator permissions to view all the conditional access policies that are configured, if you use the internal version of the API, then any user can see which conditional access policies are active. And it includes which IPs are considered internal network and which other conditional things you have. And you can see a lot of details here that you can't actually see in the portal. So here I'm looking at the baseline policy to require multi-factor authentication for administrators. And you can see that there's a whole policy definition which basically says if you belong to this and this group, you need to control MFA to log in into the Azure portal or any other resource. Now, of course, if we can see this definition, but we can also change it. So if I change the MFA control to simply say allow, then it will basically always say, okay, you're allowed to log in, instead of you need MFA to log in. And in the portal, it only shows that a policy is enabled or not. So if I change the control using the undocumented API, the portal will say, okay, this baseline policy, hey, it's enabled, it's enforced, and you need MFA to log in if you're an admin. But it's actually not true because I changed the definition, which isn't visible, so the policy is not enforced anymore. And because this is not an officially documented thing, then the details on the properties, if I modify the policy, are also not visible. So it just says, hey, some properties were updated of this object, but it doesn't say which properties or which details. And when you sign in as an administrator, because the policy just says allow instead of you need MFA, you're able to log in without multi-factor, and it will just say, okay, the condition access policy controls passed. So the short version of this is that the details on conditional access policies and their actual definitions were only available via an undocumented API. You couldn't see this in the portal, and you couldn't really figure out if this was changed or modified or backdoored in the logs. So what you could do as an attacker is like exclude specific users from policies, disable the entire policy, remove the policy, change trusted networks. And this is obviously kind of a thing, because no one, I don't think anyone is checking these undocumented API versions for change to the access policies. So I reported this, and this should be fixed last week. So it shouldn't be possible anymore to like backdoor these conditional access policies without anyone noticing. Now, we're going back to service principals and application administrators a bit, because it turns out there are some more properties or some more interesting stuff that you can do with this. So let's talk about OAuth a bit more. So there's something that's considered a reply URL. So if you have a web application and you try to log in with Azure AD, then there has to be some way for the web application to redirect you to the login page and afterwards get the token that's used to actually access the backend APIs. This is called the OAuth implicit ground flow, and it's mostly used for client-side or JavaScript-based web applications. And then deploy a whitelist of URLs, because of course if you could send the access token to any URL, then you can just pretend to be an application, forward the user to a phishing link, and then you get the access token sent to your rogue URL. So there's a whitelist of this. And once you use one of the whitelisted URLs to log in, then the access token is sent via the fragment identifier in the URL. Now, some things that you shouldn't be doing in reply URLs, a non-HTTPS URL, of course, unencrypted HTTP means that anyone could potentially spoof that site. And the portal doesn't allow you to specify HTTP reply URLs. However, the API doesn't perform any checks and just says, okay, well, that's fine. Expired domains, if you don't control a domain anymore, that your application is whitelisted, then an attacker can just buy the domain and attack the application that way. And of course, a relative URL is usually not resolved via DNS, but via broadcast protocols, which is something that we've known from our Active Directory already, that it can be abused by attackers as well. So what happens when you don't do this? Here's a little demo. Hope it works. So here's an admin logged in into his mailbox. He closes it, and he connects to a Wi-Fi network. and there's suddenly an automated pop-up, and then his access token gets sent to an attacker-controlled website, meaning that the attacker can read any emails as is displayed here on the screen. So this website grabs the access token, and it actually uses it to connect to the APIs and display all the email that the user had access to on the website. But it could as well send an access token to the attacker server, and then he has access to all the emails of a user. So this is obviously bad. And it turns out that there were at least a couple of default applications that had an insecure reply URL, such as the Microsoft Teams web client, which had whitelisted http://dev.local. And well, of course, dev.local is not a DNS resolvable name, so anyone that controls the DNS server or is in a broadcast domain can basically say where this URL points to. Microsoft Teams has read-write access to email, to SharePoint, to OneDrive, so it can access a lot of stuff. And of course, this means that this single non-secured URL allows for a person-in-the-middle attack, where if you join a rogue network, then the attacker can immediately gain access to all of your things just by sending you to the sign-in URL with Microsoft Teams and dev.local as a redirect. And it's not possible to identify this in the logs, because in the sign-in logs it just said, okay, you signed in. It says you sign into Microsoft Teams, but it didn't say that which URL you used to sign into Microsoft Teams. This was also reported and fixed. So it was fixed for new Office 365 tenants in September, and in existing tenants actually this month. And if you want to read more details about this, I also wrote a blog about this, and it lists some more of the technical stuff behind it. All right, so there's another property that's set on the service principles, which is called app metadata. And this is not visible in the portal, it's not visible in the official API versions, but if you use the internal API, you can read this property. And it's mostly used for non-default applications, so you can use it for federated certificate storage and other stuff. And there are a few applications that use this property to store application data by default. There's an interesting case here called the device registration service. And what it does is it's the application which basically controls the settings of devices that are joined to Azure AD. So this is how on the left is how it looks in a portal. So this is a widget called device settings, where you can configure which users are local admin on the devices that are joined, and who can join devices to Azure AD. And this is a setting which is normally not configurable by application administrators. But because it is a property of a service principal, then the application administrator can actually edit this and modify these settings. So taking a bit of a closer look, we see the property here called SIDS, and that stands for security identifiers. And people who know more about Windows internals or Active Directory stuff are probably very familiar with security identifiers, because they're used a lot in Active Directory on-premise, for example, in Kerberos tickets. But they're also used in Azure AD. And there are a couple of principles that have security identifiers: users, groups, and roles. These are stored in the cloud security identifier property. And once again, this property is not visible in the portal, it's not visible in the official APIs, but it can be queried using the internal API. So what can you do as application administrator? You can add a new security identifier to the policy of who is administrator in the metadata property. And that can be a user, can be a group, or can be a role. And if a new device gets then joined to Azure AD, then your rogue user is now suddenly an administrator on this device. And this is considered by design for now, so it's not yet fixed. So as an application administrator, you can modify some hidden settings and actually add a user to newly joined devices. I haven't figured out a way to add it on all existing devices. I'm not sure if it's updated at some point, but it seems to work for new devices. The portal isn't very happy with this. It doesn't understand that you just modified some of the properties, and it's kind of errors out with internal server error. So it is sometimes a bit obvious that something happened with it. but it's still a way to escalate privileges. All right, so linking up the cloud and anything you have on-prem. So previously, we've already talked about administrator accounts, application administrator. These are quite high privilege roles. So hopefully these are protected with MFA, and an attacker can't just gain access to these roles. So what about on-prem? Because we know from experience that these get hacked very often, and it's usually a lot of legacy stuff, not very well secured. So maybe it's also an attack vector for the cloud. So if you want to link up Azure AD with your on-prem Active Directory, that happens usually using Azure AD Connect. There are some older tools, but Azure AD Connect is the tool you should be using right now. So it's installed on-prem, and it syncs AD data to Azure AD, and sometimes also data back if you configure that. And if you want to have your existing users automatically sign into Azure AD, then you can use a couple of different scenarios, and the most common ones are password hash synchronization and ADFS. And in the password hash synchronization, what it basically does is it takes the hashes from the on-prem AD, and it basically pushes those to Azure AD. So the passwords match up, and users can sign in both in the cloud and on-prem with the same password. Now, previously, it was actually what got me started looking into this. I figured out it was possible to create a new account on-premise and have that linked to an existing account in the cloud. And what you also could do is use an application or an admin account in the cloud and have your newly created user with the password you control synchronized to that admin account. So that was an attack venue, which if you could create users on-prem, you could take over any admin without multi-factor. That was fixed. Some more details are also in this blog below. But there are still some attack venues left for the sync account. So if you use password hash synchronization, then the sync account obviously has to have access to all the password hashes. So that means that it's basically domain admin, and if you control the sync account, you can just pull all the hashes from AD and impersonate any user. And regardless if you use password hash synchronization or ADFS, the sync account has high privileges in the cloud. And for now, you usually see that the on-prem is considered still more important than the cloud, but maybe in a couple of years, then companies will have limited things on-prem and a lot more in the cloud, and the cloud assets may actually extend beyond the AD domain that they have locally. So I wrote a tool to actually extract the password of the sync account, because it's stored encrypted in various ways. But if you have administrator access to the host that it's installed on, you can dump this password and username and password for the account. And there are actually quite some privileges that this account has. So one of the first ones that you see in the documentation is that it can update and create policies, which conditional access policies that you just talked about are also part of. Also, the sync account can update service principals, and it can update properties, and it can add and update credentials. So it has quite some similar privileges to the application administrator, and there are quite similar things that you can do with this account as well. So some fun or bad stuff, depending on your perspective, that you could do with a sync account. Of course, if password hash synchronization is in use, it has access to these password hashes, and you can dump them if you control the account. You can also log in with this username and password on the Azure portal, because it's a user. I don't know if there's any legitimate reason for this to be possible, but you can. And you can bypass conditional access policies for admin accounts, because it's a user account, but at the same time, it's not controlled by a user, but it's stored on a computer somewhere, and it's used in an automated fashion. So if you have the default conditional access policy that requires MFA, then the sync account will be excluded from that, because it cannot use MFA. The sync account can also add credentials to service principals, so it can do the same, obtain the same privileges as the application administrator can, and it can access properties, it can access SharePoint files, OneDrive, etc. Modify service principal properties. So all the hidden and undocumented properties can be modified by the sync account. And lastly, because it has privileges on policies, it can actually remove, modify, or backdoor conditional access policies using the internal API. So what this means is that the account that by definition is excluded from most conditional access policies can actually edit those policies and mess up your whole security in the cloud. And something we didn't talk about yet is the Azure Resource Manager. So Azure AD is also used as an identity source for Azure Resource Manager and the role-based access controls. So if you use role-based access controls assigned to service principals, then the application administrator can also control these service principals and then have privileges in the Azure Resource Manager. And if you use something like Terraform to automatically deploy your VMs and networks, then this needs a very high privileged account in Azure Resource Manager. So once you compromise the on-premise sync account or an application administrator, you can modify credentials, add credentials, and basically take over other cloud resources. Lastly, a few things to conclude. So the internal API version gives quite some insight into how Azure AD works. It was less of a goldmine than I initially hoped, but there are some very interesting properties and things you can modify. Application administrators are way more powerful than you would initially guess, because everything is an application and a lot of things are stored as properties of applications. So if you're administrating Azure AD, you should try to avoid global application administrators that have access to all the applications, but try to use scoped roles or custom roles that can only manage a subset of applications. Service principals can be backdoored or abused, so make sure to monitor for credential modification. There really shouldn't be any reason for people to assign credentials to built-in Microsoft applications. So as soon as that happens, it's a big red flag. Review credentials assigned to service principals. You can't do that in the portal, but you can query them via the API. And also review the owners, because you can assign a user as the owner of an application, and then that user can assign credentials again. And make sure to review permissions that the applications have, and reply URLs for potential insecure URLs. Some more, of course, it may sound obvious, but a lot of people don't do this yet. Use MFA. Use MFA for all admin accounts for sure, and preferably for all accounts. There are some very nice statistics that it stops, I think, 99% of all attacks. So as long as you enforce MFA, then you can stop worrying about most of the stuff that I mentioned here. And once you have a bigger company and you have more resources in the cloud, really start using conditional access policies. And not only use them, but also make sure that you monitor if people make modifications to these conditional access policies, because that should be quite rare and a limited subset of people. And the Azure AD sync account has very high privileges, on-prem and in the cloud. So make sure to, if you use the tiering model, treat it as a system that belongs to tier 0, and monitor from sign-ins of the sync account for any IP that's not regularly used or application that it doesn't regularly use, to make sure that if someone compromises this account, that you can actually see that it happened. And lastly, there's a very good presentation called Attacking and Defending the Microsoft Cloud that Sean and Mark gave at Black Hat this year. And they have a lot of practical advice for securing Azure AD and actually getting to a more secure level use compared with attacks that are actually used today a lot. Because a lot of the things I mentioned are still very new, so not used in the wild yet, as far as I know. But they have very good recommendations for things you should be worrying about today. So make sure to check that out. So this was it. I hope you enjoyed it. If you have any more questions or you want to chat about Azure AD or Active Directory security, I'll be around. I'll also be in the speaker's corner, so make sure to catch up and let me know. Thank you.